So chapter 4 really ties together things that we've looked at in the previous 3 chapters, and it lays the groundwork for everything else we're going to do in this class. So here's a unit circle with some special angles marked, but what I want to show you is how our angles rotate, and we did talk a little bit about this in class when we were talking about chapter 3. So to recap, let's draw our reference triangles, because we're going to use them. In particular, I'm going to use the 30, 60, 90, so I'm just going to draw that one this time. So this side is 1/2, this is root 3 over 2, and this is 1, right? And we know that our ordered pairs x comma y are in the form r cosine theta, r sine theta. But in this circle here, this is a unit circle. Okay? So our radius is 1. And so our x-coordinate is cosine theta, and our y-coordinate is sine theta, okay? And then we know that tangent of theta is the slope of the hypotenuse of the triangle that we're going to draw. Okay, so what we looked at was, okay, if I wanted to find sine of 30 degrees, what I could do is I could draw this right triangle here, right? And so I can go through and I can find sine of 30 degrees. And that is 1/2, right? But what happens if I wanted to find sine of 150 degrees? Well, 150 degrees is here, right? But instead of trying to figure out what to do with this oblique triangle, or obtuse triangle, what I could do is I can drop a perpendicular here and know that my reference angle is 30. Right? This is still a magnitude of 30 degrees, right? So I can know that my y values, my sine, is positive in this quadrant, so that sine of 150 is also 1/2. Okay? So let's take it one step further. What happens if I want to find sine of 210 degrees? Well, what I do is I reflect that exact same triangle down here into quadrant 3. Okay. Now my sine is still a negative y value, or it's not still. It is a negative y value because we're in the third quadrant, right? So the y values are negative, but this distance here is still 1/2. Okay. So sine of 210 is negative 1/2. Similarly, if I wanted to figure out what the sine of 330 is, right? This to here is a 330 degree angle. But all I'm doing is I'm reflecting a right triangle, right? Sine is a height. We are a negative height here in quadrant 4. My reference angle is 30, so sine of 330 is negative 1/2. Okay. Similarly, I can do some things for cosine. So I'm going to find cosine of 30 degrees. Okay. So cosine is an x value, right? So in quadrant 1, my x values are positive. And in fact, it's positive square root of 3 over 2. Okay. But what happens if I take cosine of 150 degrees? Remember that 150 degrees takes you to here, right? And this is my cosine value, right? It's an x value. Notice that it's negative, right? So in quadrant 2, cosine is negative, and so cosine of 150 is negative square root of 3 over 2. Similarly, if I look for the cosine of 210, right? 210 goes all the way to here. We're in quadrant 3, cosine is still negative. Okay, because my x-coordinates are negative, and so cosine of 210 is also negative root 3 over 2. And last but not least, if we're looking for the cosine of 330, right, we come all the way back around to quadrant 4. Well, what do you know about x values in quadrant 4? They're positive, right? So that means that the cosine of 330 is the positive square root of 3 over 2. Do you see how that works? Alright, so before we're done with this, let's look at tangent. I'm going to do that in blue. Alright, so we're going to look at tangent of 30, we're going to look at tangent of 150, we're going to look at tangent of 210, and tangent of 330. Okay, so the basic idea is the same. right? Well, tangent is the slope of my hypotenuse, right? So that's these diagonals here. Well, in what quadrant are my slopes positive? That's 1 and 3, right? So tangent of 30 and tangent of 210 are going to be positive, okay? And then the slopes of this line is negative, right, in quadrant 2 and quadrant 4. So that means that tan of 150 is going to be negative and tan of 330 is going to be negative. Well, all I need to do is to figure out what tangent of 30 is, and that will help me get the rest of these tangents, right, because all of them have a reference angle of 30. And I'll define in the next video what a reference angle is and how you go about finding it. I think it's in video 2. Yeah. Okay, so tangent of 30 is opposite over adjacent, which gives me 1 over the square root of 3, and we know that that simplifies to the square root of 3 over 3. Okay, so tangent of 30 is root 3 over 3. Tangent of 150, that's here in quadrant 2, that's negative root 3 over 3. Back here in the third quadrant, our slope is positive, so tangent of 210 is positive root 3 over 3. And then back all the way around again to quadrant 4, our slope is negative again, and so tangent of 330 is negative root 3 over 3. Okay, and that's basically it, right? So it's important to be able to draw a picture and know that x corresponds to cosine, y corresponds to sine, and vice versa. Tangent is the slope. And so if you remember your reference triangles, you can go around and find the sine, cosine, and tangent of all the angles whose reference angles are 60 degrees and all whose angles whose reference angles are 45 degrees. And that way you don't have to memorize all these points on the unit circle. Okay, and you can solve any triangle out there.